Hello again. Thank you for introduction. My name is Dmitry, and I will make a short overview of Fluence, a decentralized serverless compute platform, and how it can help compute providers as well as developers. So, as I said, Fluence is a decentralized serverless compute platform, and we can question actually every word here. What does decentralized mean? At least it means distributed and in some sense trustless. So you need to reason about the trust. It should be unstoppable, censorship resistant, fault-tolerant. That's probably the minimum. And the words compute platform for Fluence means that Fluence replicates the cloud stack. So you can build the whole application based on that. A little bit more detail. The objective of Fluence protocol is to run arbitrary code without limitations with a similar speed and utility as the cloud. So I want to run code anywhere, on the edge, locally, in the browser. We want consensus to be opt-in or like optional to reach high performance. We want to be fault-tolerant, secure, asynchronous. That means that transactions or operations or function calls shouldn't be in a sequence. We should be able to run them in parallel if we want to. And we want it to be compatible with multiple data inputs and outputs like IPFS, Filecoin, or Weave, different chains, other protocols, proprietary data sources, and so on and so forth. Because mainly we're about being the cloud, not about doing everything for all the world. So speaking about the consensus, we can say that there are two very different kinds of decentralized compute. On one hand, we have blockchain compute. We have smart contracts on chain. And fundamentally, it's sufficient for deterministic processing, for redundant, constrained, expensive. Why expensive? Because we repeat the same computation many times and the same data many times. So there are some limitations which also open possibilities, but they are constraints. For the general purpose compute, which is 99% of all the web compute actually, we need to provide computations with non-deterministic side effects. Otherwise, it's kind of useless or it's already covered with the blockchain. So we want to have a universal runtime to run computation cheap and fast, to be permissionless, and run anything. So again, why decentralized compute? Why do this at all? And why to make a new software stack for that? We expect it to be cheaper, and Filecoin is a good showcase how Web3 economy can make services cheaper. We want to free developers from the cloud lock-in to enable them to switch providers. We want to be deplatforming resistant, to have no API to shut off, as there is no API, no way to deplatform anyone. We want to accelerate innovations, and for all of that, we need to be verifiable or auditable in terms of computation and proving that compute has happened. How the price is going to be lower? How could it be cheap? So Fluence runs on a decentralized compute marketplace, and anyone who has a spare CPU time can contribute compute capacity. Open protocol eliminates switching costs between providers, and with no switching costs, there is competition which drives down the compute costs. Yeah, and we already saw how it works with Filecoin. And for traditional clouds, it's not the case. A few providers of cloud services control the majority of the market, and their revenue is growing pretty fast because once you integrate one of the computer providers, one of the cloud providers, it's very hard to leave. It's very hard to switch. And that's why decentralized compute networks are good because providers can be changed at will, no switching cost, no lock-in, because that's the protocol. Another point is that we have deplatforming risks. Clouds can shut off an application for any reason. And not only clouds, APIs can also ban the users of these APIs, or they can change or shut down the API itself. And the majority of infrastructure, Web3 decentralized infrastructure, is either just centralized backends of DApps, or it's centralized developer APIs that DApps use. With decentralized compute, we have no API to shut off, no deplatforming risk. And another point is that centralized compute prevents collaboration and innovation. You know this walled garden model, when all the data and all the compute resources is surrounded by the walls of some corporation like Twitter, Facebook, and so on, which prevents developers from adding to existing applications and platforms. In decentralized networks, we have composability of protocols, which is nice. So all of this constitutes a new generation, a new step in the evolution of compute. We had mainframes, we had centralized cloud platforms, and now we're opening the era of decentralized serverless compute platforms. That's happening right now. But that means that it hasn't happened before. And that's because making the real open decentralized compute hard, especially it's super hard, extremely hard to do it without blockchain. Because we want to be verifiable and scalable at the same time, and I want to run compute on generalized compute capacity. That's hard. But now, thanks to the concept like web of trust, different consensuses, and ZK proofs, we can build the model that will help with that. So Fluence is not a blockchain. It does run on blockchain, and the competition is more like AWS or something like that, not blockchain smart contracts. So we can look at Fluence decentralized serverless compute platform from two different angles. It's a developer platform, and for the developers, it offers serverless compute functions and workflows. And for the compute providers, for data centers, it's a computing marketplace, a decentralized network for compute providers. For the developers, the simplest analogy, not super precise, but simple, is that we have something like AWS Lambda, Cloud Functions, and we have a WebAssembly runtime for that called Marine. We have an analogy for AWS step functions, distributed algorithms, and that's Aqua in Fluence. And the protocol itself ends on this step, and all the other behaviors are actually distributed algorithms like load balancing, routing, scaling, orchestration, deploy. And all of this can be done in the scripting fashion as the Aqua libraries. So we can collaborate on that. And computing marketplace is where service providers and developers meet each other, and developers aim at low price, decentralized compute capacity with all the security guarantees like auditability provided by the protocol. And service providers can monetize their capacity with the capacity incentives that we have. So that's about the new revenue stream for FIL miners. So Fluence is another way to bring compute to the data. We had the previous talk about FVM. Fluence solves similar problem, but with a different approach. So miners earn from unused CPU compute capacity, not GPU. We are utilizing CPU. And compute unlocks values in stored data. As FIL miners already have data, they can benefit from it more. After selling CPU is free, and compute providers can monetize CPUs. Yeah, we expect that compute demand will grow because more data, more needs to compute, more ways to compute, more different jobs. So monetization will increase the revenue. And to have this revenue from useful work made on the network, we need to have verifiability. We need to have a variety of proofs to distribute the incentives. And we have three kinds of proofs. The main one is the proof of processing that proves Aqua, the distributed workflows. So it's verified by every peer on the way of execution of the distributed algorithm. And after that, we have probabilistic verification on chain. You can ask which chain. I hope, and the goal is to use FVM. We're going to run on FVM. Verification should be done on Filecoin. Another part is proof of execution. That's the proof of actual compute. This topic is a bit more difficult because if you want to have effects, then it means that not everything can be verified. That's why I have these brackets around ZK. So some parts can be verified with ZK, some with cryptography, some with consensus. In Fluence, it's kind of pluggable. So we support different kinds of compute verification. And this verification comes as part of the proof of processing. And we have proof capacity that incentivizes providing compute capacity to subsidize the supply side of the compute marketplace. And that's for miners to join. So yeah, storage and compute together forms decentralized cloud. So a lot of synergy between Fluence and Filecoin. We did actually all the stack. We have WebAssembly runtime that was the first to run interface types for WebAssembly. It runs well-typed WebAssembly in JavaScript, including browser. We have CLI, we have Aqua libraries, we have the showcase for decentralizing in Fura with FRPC. We raised 15 millions, and we have our testnet live. Just a few words about the roadmap. As we're on the testnet currently, it means that we aim going live, and we expect to have our mainnet running on FVM in Q4. And this release should be mainly focused on the most fundamental proofs and on the proof of capacity for the compute providers. And next year, we'll be working on more proofs, more languages, and better developer experience. Yeah, we raised 15 million from top investors, including PL, which is super nice. We have some founders, Tom Trowbridge, Evgeny Ponomarev, and me. Yeah, and we have a mission. Fundamentally, it's kind of slightly insane project because we really want to make decentralized compute really decentralized, like no compromises. And that's kind of very visionary. And we really want to empower the next wave of internet innovation, remove these blocks made by Web 2 approach and so on. So that's what we are working on. Yep, that's all from me. Fluence.network. We have Discord, Fluence.chat. I'll be around today. Would be awesome to discuss anything. Especially, I like discussing proofs. And we are hiring. Thank you very much.